beam width 12. T total thickness 16. Gamma concrete. Anybody remember what is the value of gamma concrete?
150.
This number put in your mind, 150. But remember, pound per cubic feet. Your unit is important. This one need feet. This one inch. Inch, so you need to divide it by 12, divided by 12 to be in feet. So your final W dead load equal 16 divided 12 times 150. Your value 200 pound per foot. So if you would like to make it in the same unit like life load, equal 0.2 kb per foot. So moment due to dead load equal WL square over 8. Simply supported beam with uniform distributed load. So WL square over 8. W of dead load 0.2. Your span 20 square over 8. I can get the moment 0.2 times 20 square divide 8. 10 kb foot. Your moment due to life load equal WL square over 8. This W for dead load, this W for life load. So your value 1.1 times L square 20 square divide 8. $55 kb foot. So your M ultimate, we have only dead load and life load, so equal one combination, 1.2 dead load plus 1.6 life load. 1.2, your dead load 10 plus 1.6 your life load 55. Your final value 100 kb foot. All of this stuff from structure analysis. M ultimate equal 100 kb. Your Rn equal M ultimate divide phi B D square. M ultimate 100, phi 0.9, B 12, D square 13.5 square. But remember this one, this moment, kb foot, and the denominator in inch. So we need to multiply it by 12. So your value divide 0.9 times 12 times 13.5 square, 0.61. Rho required. Anybody remember?
0.85.
0.85 FC prime weight. I selected everything in kb and inch. So what's the value of FC prime? 3 or 4? 3. 3,000. Divide F yield 60 time 1 minus square root 1 minus 2 Rn 0.61 divide by 0.85 times 3.
Dr. Raymond,
Yeah.
since we changed that to inch, aren't we in inch?
Yeah, everything in inch right
Oh.
now. Kb, this one, KSI means kb and inch square. KSI, and this one, kb and everything in inch. So everything right now in kb and inch. Okay? Minus 2 times 0.61 divided by 0.85 times 3
Conversion.
plus 1 square root 9 minus 1 plus 1 time 3 time 0.85 divide 60. Your final 0.0118. So I think I can get my area still required equal rho time B time D. Rho 0.0118 time B 12 time D 13.5. I can figure out what is the value of your steel 1.91 inches square. Before converting it to number of bars, we need to check what is the minimum, what is the maximum. Your minimum 3 square root 3 kib KSI divided by FE 16. But this value should be in PSI.
The problem doesn't tell us it's 60,000. We assumed it.
It's not given? I think it's given.
Grade 60.
That's for reinforcement.
Yeah. That's the
Oh.
value source here.
We have 3,000 PSI. Okay, so 3 times square root 3,000 divided by 1,000 0.003. This one will be okay because your rho required 0.0118, so it will be greater than the minimum. For maximum 0.85, beta 1 0.85. Anybody know why beta 1.85?
PSI on concrete.
Yeah, if you remember, F prime C smaller than or equal 4,000, beta 1 equal 0.85. If F prime C greater than 4,000, we have another equation. If you remember, go back. Anyway, FC prime 3,000 divided by 60,000 times 38. Your answer will be .0135. Anyway, keep going. That means your area steel maximum equal rho time B time D. So time 12 time 13.5, I think. Your 2.2 inches square. Wow, so your area steel required greater than your minimum, smaller than your maximum, you are good. Your area steel equal 1.91 inches square is good. You can convert it to number of bars if you select number 3. Number 3, your area of 1 bar, 0.11 inches square. So number of bars equal 1.91 divided by 0.11 will be a big number. Yeah, 17, it's too much. You can choose number 4 or number 5 and get your number. Any question? So right now we can figure out what is the required steel reinforcement for a given or calculated ultimate moment from structure analysis. Actually, last information in this part, we have three type of section. First section, first one, we have steel reinforcement. This shape called strain distribution. That's right. But before starting this point, I would like to remind you for something. What's this? Stress strain curve for steel reinforcement. At this location, we have sigma yield. At this location, we have epsilon yield. Epsilon yield, or before epsilon yield, your E, Young's modulus, equal stress divide strain. If you would like to get your strain, equal sigma divide E. If your strain is yielding, your stress will be yielding, or F yield divide E. F yield for steel reinforcement 60, KSI 50, any number. Divide E, Young's modulus of steel. I can figure out what is the value of yielding. The first type of cross section called balance. Cross section. I'm sorry, what is the meaning of balance cross section? Means your concrete reach maximum capacity, at the same time your steel reinforcement reach yielding. Both of them reach the maximum capacity at the same time, which called balance cross section. One more time, balance section, your concrete reach the maximum capacity, at the same time your steel reach the maximum capacity. The second one, your steel reach yielding first before concrete reach ultimate. So this one yielding in steel first, then concrete failure. This cross section called under reinforced section or steel controlled section. Anyway, the third one, epsilon T strain in steel smaller than epsilon yield. Steel did not reach to yield, but concrete reach ultimate. So concrete crush, but steel did not yield. Which cross section do you like? Do you like concrete to fail first before steel?
No.
Do you like steel to fail first before concrete? Do you like both of them at the same time? The most economic cross section, this one. You don't have waste material. You adjust your concrete as required exactly. You adjust your steel reinforcement as required exactly. But this cross section called ideal section. We cannot reach this cross section in the real life. This one, we prefer this one. Most, maybe 100% of our design must be like this. We need yielding first. Yielding happen in the steel reinforcement, then crushing in concrete. Because this cross section will give you some prediction. As you see here, yielding of steel reinforcement does not mean failure. Your steel reinforcement can expect more and more and more. But if you reach maximum capacity of concrete, after this point, we have sudden failure. So if we have yielding, we can expect cracks in the bottom of your beam. Hey, we have something wrong in this beam, so we can expect failure. But this one, no yielding, no cracks, but suddenly collapse will happen. So this one, brittle failure, this one, ductile failure, this one is the ideal situation. We cannot reach this one in the real life. Anyway, how can I judge this cross section is balanced section or under reinforced section or this one called over reinforced section? By the way, over reinforced section, you have too much area steel. Under reinforced section, you have area steel required. Not too much, not too many. Required. So it's not good to add more and more and more reinforcement. You can reach this situation. You have more steel reinforcement, yielding will not happen, crashing will happen first. Brittle failure. We need to fall in this situation. Yeah, one more thing. What will judge this situation or this one based on what is the strain